All right. This is the proof. And the proof is going to be done. That's his proof right there. And the proof is going to be done in a couple of stages. The first stage, going the first direction. So the first direction, right, we're starting from here and going to here. So I'll say, like any direct proof we do, right, let n be a particular but arbitrary element of S, right, because it all comes from S, with three divides n. So we're assuming n meets our conditions. Just assume we have any old n, any particular arbitrary n, there's a and s, and you get 3 divides n. That's how all of our direct proofs start. Then, note, since n is in S, by definition of S, because S is all these numbers here that can be written like this, there exists an A0, A1, A2, A3 in 0 to 9, such that n equals A3 times 10 cubed plus A2 times 10 squared plus A1 times 10 to the 1 plus A0. That's just by definition of being an S. We haven't done anything special yet. All right. Note. Here's where the special part comes in. N equals A3 times 10 cubed plus A squared times 10 squared plus A1 times 10 to the 1 plus A0. This is by substitution, which equals A3 times 1,000 plus A2 times 100 plus A1 times 10 plus A0 by evaluation, or is evaluating what 10 cubed and 10 squared and all that means. And this equals 999 plus 1. 100 equals 99 plus 1. And 10 equals 9 plus 1. Right? And all this is by observation. Just observe, each one of these, 1,000, 110, are all going to be one of these 999 things plus 1. 99 plus 1, 9 plus 1. They're all going to be like that. The important thing is they're one more than a multiple of 3. Now, if we write this out, this is going to be A3 times 999 plus A3 plus A2 times 99 plus A2 plus A1 times 9 plus A1 plus A0 by distribution. And what's this equal? this is going to equal, I'm going to group them in this way, 999 times A3. This is because multiplication is commutative, and it looks weird to me to have a variable in front of a number. We normally put numbers in front of variables. Doesn't matter. 999 A3 plus 99 times A2 plus 9 times A1, right? If we group these three together, then what's left over is A3 plus A2 plus A1 plus A0. And this associativity is by associativity, just meaning that we can rearrange this however we want. So far, all we've done is we've just said because n is in S, it can be written like this, and being written like this, if we just kind of rearrange some stuff using pretty basic algebra, we get to this. And I don't want to erase this, so we're going to continue with pen and paper. All right. So, right, if we keep going, right, we know it can be written like this. Then, note, this is actually like a marker. Maybe a better pen. There we go. Note, 999 A3 plus 99 A2 plus 9A1. This right here. This equals 3 times 333 A3 plus 33 A2 plus 3A1. Right? Just write it out. Thus, 3 divides 999A3 plus 99A2 plus 9A1. Right? That should make sense, right? I'm saying it right a lot. Then, since 3 divides n and 3 divides our 99A3 plus 99A2 plus 9A1 by our red fact above, right? By that fact above, 3 must divide n minus 99A3 plus 99A2 plus 9A1. But timeout. What's n? N equals this. N equals 999 A3 plus 99 A2 plus 9 A1 plus these guys. That's n. So n minus this we'll have that right there. These two cancel. So this equals A3 plus A2 plus A1 plus A0. Hence, 3 divides A3 plus A2 plus A1 plus A0, meaning 3 divides the digits of n. Actually, we're not squared yet. We're done with the first part. Now, here's the thing. Even if our aside conversation didn't make a ton of sense, that was confusing, I hope that every step I made here along the way made perfect sense. And if every step I made along the way made perfect sense and it leads to this conclusion, that means this conclusion must be right? Because like if you have a valid argument with true premises, then you have a true conclusion. So, on that vein, does anyone have any questions about this? Seriously, try to point out, is there anywhere in this chain of reasoning that you're not sure about? Or that doesn't make sense to you?
There was something that bothered me a little bit, and I think it's fine, but it's like the by the red fact above, but you can, it would be better to rewrite it as 3 divides n plus negative of
Oh, you're right. You're right.
1 and so on.
What I'll say
but
then
like,
is, to save my proof, I'll change this fact to b minus c, which is also true. And this is true because if a divides c, then a will divide minus c. But yeah, but you'll see why that's true when you prove it on the homework. It's not hard.
I mean, no, like I still agree, but that's
yeah,
just
no, you're right there. You're right there. That's a little bit. But anyway, but anyone else, right? So we just started out by assuming ins and s with 3 divides n. So we just assume that we're in our domain and we have the predicate. And we're trying to prove the conclusion. And, well, by definition, we have the first part. By definition, there exists these numbers, since you're in S, there exists these numbers that work this way. So you get A1, A1, you get A0, A1, A2, A3, that equal n, right? Like that. That's just by definition, that's fine. But then we can rewrite that as this whole thing. And then we notice that this part is divisible by 3 because we can literally write it as 3 times, and then we can write down what that is, right? And then we have 3 divides n, and 3 divides this part. So 3 will divide n minus this part by our fact, meaning it has to divide this part, which happens to be the sum. The sum of the digits happens to pop out if we write it correctly. This is kind of brilliant, right? I think maybe a lot of this felt like we were kind of trudging through some algebra, right? But if we take a step back and look at it, this is kind of brilliant. We were able to prove that if 3 divides n, and 3 is a 4-digit number, or n is a 4-digit number, then we're going to get that 3 divides the sum of the digits just simply by rewriting n in a super clever way. This happens all the time in math, where math most of the time, the way things are actually proved is by just simply changing your perspective, right? So instead of looking at n as this, as a 4-digit number like we typically do, look at it like this. And if you look at it in this changed perspective, it's very clear then that 3 will divide this, because 3 divides this, and 3 divides this, so 3 will divide this minus this, which is this. I've said that before. The point is, just changing our perspective here made it obvious. And so really the only thing we had to do is prove that our perspective change didn't change the meaning, which it doesn't, because they're just equal. Any questions? I have a question. Are we done with the proof?
No, we still have to go the other way.
Yeah, we have to
Okay.
prove the other biconditional.
Yeah, so next time we'll do that where we still have to prove this way next time. And so that means if you start here, if you start with this assumption that you can write in this way and 3 would divide a0 plus a1 plus a2 plus a3, then prove 3 divides n. It's going to be just as easy. It's basically just going to be reversing what we already did. But we have to prove it. And that is class. So, I hope that the takeaway from this class is that I want to show you guys something a little more complicated. I hope I didn't overstep my bounds. Just to kind of show you guys that this proof thing, it's more than just, like, even when we know right now, it's more than just proving that, like, an even plus an even's an even, right? We can do that, right? But it's more than that. We can actually prove some pretty interesting, non-obvious stuff here. Like, you might have heard this rule in elementary school. You can do this division rule, right? But unless you teach it like Alex, you probably never knew where it came from. And most people might know this exists, often might know this exists, but never, ever, ever question or know why it works. Like, how would you prove it about everything? That's how you prove it. The one caveat here, and that'll be class. That's class. That's class. Thank you, everybody. I'm going to stop recording.